The aircraft industry has gone through some dramatic changes recently, and a lot of these changes have focused on the use of composite materials for the primary structure of aircraft. And this has really been driven by three market demands. The first market demand is the desire for increased operational efficiency and generally increasing the fuel efficiency of aircraft. So the use of composite materials can help to lighten an aerostructure, and by lightening the aerostructure, you'll have a much more fuel-efficient aircraft. The second desire is for reduced service costs. Using composite materials, you can actually extend that cycle because of the nature of these materials. The third area is in the use of composite materials to create an airframe and an aerostructure that's more comfortable to fly in.
The aerospace industry is trying to now go from building a composite part to optimizing that composite part so they can achieve weight savings. If you reduce the weight of the aircraft itself, you can increase payload and you can reduce the amount of fuel that you use over a particular mission range, and that's really where the cost savings is going to come.
Being able to reduce the weight, though, is not necessarily a straightforward process. You can't just substitute composite material for the aluminum structure that was there before. Frequently that's referred to as black aluminum or black metal. What you want to do is make sure that you design the aerostructure using all the unique traits and capabilities of the material, and then make sure that that process that you use is as efficient as possible.
FiberSim actually benefits an aerospace company because they can actually go through several iterations to achieve the highest level of optimization for a composite part in terms of weight, in terms of amount of material used, in terms of throughput in manufacturing, because of its openness and its ability to exchange information between an analyst, a design engineer, and a manufacturing engineer.
FiberSim allows you to do a very good job at controlling fiber orientation, which gives you more confidence in your margin and ultimately allows you to create a reduced weight aircraft that will meet those operational demands.
Composite material is so difficult to work with because of the number of parameters that are associated with that material. With a metal design, you know what it is, you know how it's going to behave no matter what. And with a composite material, you have that interconnection between, the shape of the part, the material itself, and how it behaves when you actually lay it up over that shape.
If you're using composite material, you want to make sure that the design engineer has a window on the manufacturing floor so they can understand the impact of their design decisions on the manufacturability.
Without a multidisciplinary approach to composite product development, all the way from preliminary design through manufacturing, you're not going to be able to fully realize the benefits of composite materials because you'll never really understand the strength that you're looking for and the manufacturing throughput that you're looking for and the material behavior that you're going to have that's sort of a result of the material, that shape, and the manufacturing process that you select. FiberSim is actually a specialized engineering software application for design and manufacture of composite parts that's integrated into CAD applications.
By being able to give design engineers an ability to have a much clearer understanding of what the fiber orientations are, that allows them to do a better job at understanding their margin, and understanding your margin will give you more confidence to be able to use less material and reduce the weight of the part.
FiberSim helps you actually achieve those weight goals by helping the whole organization understand how to get to an optimized composite part.
Our strength is that we have a complete suite of applications that provides for a cross-disciplinary workflow to be achieved in the development of composite aerostructures. We have a world-class CAD system. We have the world-leading PLM system for airframe and aerostructure development. And we have the world-leading tools for composites design and for the integration of those composite designs into the overall aerostructure. Those products altogether allow you to be able to get to a much higher performance process and ultimately be able to produce better quality, higher performance products for your customers.